This is Chapter 11, Section 8. The concept for today is to simplify sums and differences of radicals. Let's consider this problem. 4 times the square root of 7 plus 5 times the square root of 7. We need to simplify that. Let's think about simplifying 4a plus 5a. Remember that what we did is find the common factor, which is a. Each term has the common factor of a. We took that to the outside, and on the inside of the parentheses we put 4 plus 5. This is the distributive property because a times 4 is 4a, a times 5 is 5a. This allows us to simplify it to 4 plus 5, 9a. Basically, we do the same thing when we have radicals. Just think of the radical as a variable. And you do the same thing. We have a 4 and a 5, and the common factor is the square root of 7. So we take the square root of 7, we put it on the outside of the parenthesis, and on the inside we have a 4 and we have a 5. And we're going to add them together. We get 4 plus 5 is 9. Final answer is 9 times the square root of 7. Let's consider this next problem. 7 square root of 3 plus 2 square root of 2 minus 3 square root of 2 minus the square root of 3. This would be similar to a problem like 3a plus 2b minus 3a minus b. You have two variables in this case. So what we do, we have to group those variables. If you were doing a problem with variables in it, we have to group them together using the commutative property and the associative property of addition. So we're going to get our radical 3's together. So we have 7 radical 3, that came from here, minus the square root of 3. You got to be careful of that sign. That sign goes with the radical. Plus, right there's where we got the plus sign, 2 square root of 2 minus 3 square root of 2. Once again, you got to be careful of that minus sign. So now all we do is group that, we use the distributive property. We have a 7 radical 3 minus radical 3. But what is right there? This is a 1. By the multiplicative property of negative 1, you can multiply negative 1 by anything and come up with negative whatever it is. So negative 1a is equal to opposite of a, or the negative a. So we take the 7 minus 1. On the outside of the parentheses, you put square root of 3 plus, and we have the square root of 2, that's the common factor. We have 2 minus 3. So now all we have to do is simplify. 7 minus 1 is 6. 2 minus 3 is negative 1. So your final answer is 6 square root of 3 minus square root of 2. Remember, you want to simplify it. Get rid of that negative 1 because remember, negative 1 times a is equal to the opposite of a. This is more simplified than that. And you're done with the problem. You cannot simplify it any further. Let's look at this problem here. 25 square root of 2 plus 2 square root of 27 minus 3 square root of 98. Now, these problems, you have to sort of look closely at them because we have a square root of 2 here. We have a 98 and a 27. Think about 27, the square root of 27. That is equal to the square root of 9 times 3. Think about 98. 98, the greatest perfect square is 49. That's equal to the square root of 49 times 2. Now we can break these apart according to the product property. We have 25 square root of 2, that stays the same. 2 square root of 9 times 3, that's equal to, and I sort of shortcut it here because you can see that the square root of 9 is equal to 3. and then you have the square root of 3, minus 3, that stays the same, and I shortcut it again. The square root of 49 is equal to 7. And then the square root of 2 stays the same. And all we got to do is group them together like we did in our last problem. I see here we have a square root of 2 and a square root of 2. Using the commutative property, we're going to get those together. So I think what we're going to do is now first we're going to multiply these together and simplify them. So we have negative 3 times 7 is negative 21. 2 times 3 is equal to 6. Okay, then we're going to go from here. We have 25 square root of 2 minus 21 square root of 2, so we're going to group those together down here, plus 6 times the square root of 3. Using the distributive property, we have 25 square root of 2 minus 21 square root of 2. And I didn't write this out, I just sort of did it in my head. 25 minus 21 is 4 times the square root of 2 plus 6 times the square root of 3. And that's the final answer. Now in your homework, if you can do some of these, like some of these shortcuts, I will allow you to do that. But make sure you know why you're doing them. Let's look at this one. Square root of 3 minus the square root of 1/3. Well, remember what we did with fractions. We have to rationalize the denominator. So we have square root of 3 minus square root of 1 over square root of 3 by the quotient property of radicals. We have a square root of 3 in the denominator, so we're going to multiply both the denominator and the numerator by the square root of 3. We'll come up with square root of 3, and I think we're going to put it over 1. You can put any number over 1, minus square root of 3 times square root of 3, that's the square root of 3 squared, and the radical and the squared symbol cancel, so you get the radicand, which is 3. Square root of 1 times 3 is the square root of 3. All right, now what is this equal to? Well, the common denominator is 3. 1 times 3 is 3, and 3 times this is 3 square root of 3. You know that's right because if you cancel the 3's out, you end up with the square root of 3. Minus 1. Once again, you can put a 1 there, and the square root of 3 over 3. What is that equal to? 3 minus 1 is 2. Square root of 3 is the common factor over 3. And that is the final answer. Summary for adding and subtracting radicals. 1. Express each radical in simplest form. 2. Use the distributive property to add or subtract radicals with like radicands. Assignment is page 541, numbers 1 through 32. I hope I've given you enough examples for you to work the problems. If not, there is a couple more videos on the wiki that go to a YouTube explanation of it.